Thanks everybody for sticking around. And coming up here, we have our second lightning round, and we have a series of seven 10-minute talks, and they cover a range of topics, and they all look pretty great. So, like I said, I don't want to cut into their time, but just to let the speakers know, I'm going to let you give you a heads up at 3 minutes and at 1 minute. And then I'm going to be a pretty strict taskmaster about cutting you off at 10 minutes so that we can make sure we get everybody in time. And for the folks that in the audience, I would count on not having time for questions. So please put your questions into the chat, and I would encourage the speakers to jump into the chat after their talk, and please address those if you can. So we're going to start out our lightning round with, we're going to welcome back James Cutler, and he's going to talk about automating R scripts. So take it away, James.
All right, can you hear me?
Yes.
All right, thank you. Hi, my name is Jim Cutler. I've been doing data science for about 14 years now, with the last year and a half as a Department of the Army civilian. I have a bachelor's in theoretical math, a master's in theoretical statistics, and a master's in computer science. My hope is that you find this useful in your work so that your time here is well spent. I've posted the links just now in the Git, to Git in the chat. Here's the usual disclaimer. I am not in any way representing the U.S. Army or the U.S. government, or anyone else other than myself for that matter. All right, we're on the next. I won't cover the overview for time reasons. The bottom line is that you'll only have to do two simple things in order to be able to call your script from the Windows command line, a scheduled task, or interactively, with almost no discernible difference. The first step is to copy my function in those Gits as is into your script, and the second is to add a line at the bottom of your script to call it. The line at the bottom is important. When working interactively, you will not see any differences after you do this. Next slide, please. Above the dash line is the full Windows command line syntax that you'd use either on the Windows command line or in a scheduled task. It has three parts: the executable provided by your R installation in red, your script in purple, and the function and its parameters that you want to call in green there with the magic R script run in front of it. Next slide, please. Here I'm just showing two different function calls. You'll notice if you have time between the big red and the big at the top and the big red in the middle that everything's the same except what's inside the double quotes of the R script run. You can see the output that you got from the others, or the highlighted output. The other stuff I'll cover in a moment. Next slide, please. Using Windows environment variables can make life easier in a lot of ways. This is one of them, but at least on my government computer, you cannot use the control panel GUI to set them up. This is a workaround that I'm just showing you if you want to use it for setting user level variables using the Windows registry editor. You cannot set all users level variables. And one thing important to remember is that when you define it in the control panel, a variable in the control panel, it immediately shows up. With this method, you have to reboot. Next slide, please. So now I've rebooted my machine after defining my XREXE variable, and I check in my command prompt, and there it is in purple. I'm using the planet variable just to show that you can define variables on the fly. Then you run exactly the same thing you did before, except now I'm saying hello %planet instead of hello Earth. Next slide, please. Let's see, so you can invoke pretty much anything, right? It doesn't have to be a function you've written. It can be a function from a package. It can be a function, pretty much anything. It can just be straight square root of 2, whatever you want. If you make a mistake, you type something wrong, like in the case on the right-hand side there, I typed goodbye with a lowercase g instead of an uppercase, and you get messages back just like you would on the console. Next slide, please. All right, Windows command line supports something called piping. If you've used dplyr in R, you're familiar with piping. Stuff goes from one place to another via the pipe. Piping gives you the ability to send both the normal and error output to a single file, or to create one file for normal and one file for error. There are use cases for both. I've shown the syntax at the top there for sending all the output into a single file. And this is where the debugging info becomes particularly interesting. In other words, the magic has put out what the name of the script is, what the parameters were, what function was called, and other stuff. Next slide, please. Oh, so of course, 6 months from now, when you've piped your output to a file, you can go and you can look at the top of the file and say, oh, that's what this file does. So anyhow, so slide 9. To use this magic in your script, just copy the setup function from sample01.r into your script, which is out there in either of those Git repositories. Then call setup on the last line of your script. Last line is important. I won't go into why, but it is. Just put it there. These changes will not affect you at all when working interactively. Next slide, please. Just in case you want your function to work differently depending on whether it is running interactively, the setup function creates 2 variables in the global environment that you can use in your functions. BR script over there on the right in blue is false if you're running interactively and true if you're running from the Windows command line. econst is, if you're familiar with R environments, just a place to put all sorts of stuff and still only have one thing showing up in the global environment. Setup puts basically all that stuff that you saw in the debugging information into econst. If you want to use it, fine. If you want to add stuff to it, fine. It won't have any impact. Next slide, please. Here's how to set up the scheduled task. Now, I did not show piping, and that is somewhat complex because I was unable to test on any government computer that I have. So you can easily find info online. The trick is that the 1 grader and the 2 grader are going to go between those last 2 double quotes that you see there at the end of %, call % double quote, about a little less than the middle or a little below the middle. And it takes some work to get it right with escaping and all that other stuff. So your better option is on the next slide. Next slide, please. And that is sample01.bat. Now, out in the Git repository, it's called .txt because a lot of government computers won't even let you download a file with .bat or save a file onto your computer or email it to yourself or whatever. So it's .txt, but it's really a batch file. It's rather dumbed down from the version I use at home just because the military locks down batch files so much. You don't have the extended commands, you don't have delayed expansion to variables, all that sort of stuff. But anyhow, this basically will get the job done for you. Essentially, my working methodology is to have a separate batch file for each script or possibly a separate one for each script, function, and parameter, whichever is more convenient. The batch file, you set a few things at the top of it and you're pretty much done. It handles, as I mentioned, it handles piping the output to a file for you. It names the file somewhat intelligently. You can obviously change that. And then if you can't run batch files like I can't, you can do a Control-A and a Control-C, copy the entire text file into your clipboard and then open a command prompt and right-click, and it will be just like the batch file. As a bonus, you can use that same technique for whatever you want, right? Like every morning I copy 5 or 10 commands out of a text file and paste them into a command prompt. So I'm downloading stuff from my various data sources that I need for the day and whatever all else. Next slide, please. All right, again, I'd like to thank you for your time and wish you all the best in your careers and lives. Any questions?
We actually do have a couple minutes if someone has a question they'd like to drop into the chat. All right, seeing none. Thank you, James.
Thank you.
All right. So next up, we have Jose Beon Santiago Calderon talking about using Julia for dissemination of information.
Good evening, everyone. Thanks for the opportunity to share some of the things that I've learned using Julia for a few years now, especially in HPC environments. What I'll be talking today stems from my work as a postdoctoral research associate with the University of Virginia, but also some of my civic engagement activities. And this case study is about election, which might be in everyone's mind today. Next slide. So there is this platform called Practica tu Voto, and it's a group of civic open sourcers or open source contributors that basically wanted to create a tool that would allow people to get a ballot similar to the one that they would be facing when they're casting their votes. And we wanted to have the correct ballot. So based on like the precinct or the polling place that they are assigned to, we wanted to have an interactive experience so they could actually fill it out. And as they fill it out, they would get explicit feedback on how those marks that they're making translate into votes for support for each of the candidates. We wanted to support all types of votes, not just the simple ones, so people are familiar with all their choices and what those actually imply, so that it gives explicit feedback on how, when they're voting. Lastly, we wanted to make sure that their ballots are valid, so we wanted to validate the ballots and also allow for exporting those so they can use it, share it with friends, social media, etc. Next slide. So this is just one aspect of education about the election. Some of the core components is actually getting to know who those candidates are, what they stand for. But here we're focusing on one aspect, which is how to vote. So on the website, we actually give some links to other partners that are doing more campaigns that are related to the overall issue of getting the electorate to be educated. Next slide. So I'm a Virginia, an Arlington resident, so I will get, or I did get a ballot, something like this, where you have the instructions, you have each of the candidacy for Congress, for president, how many marks you can support, and it's pretty simple. That is not the case in most jurisdictions. Usually you have more alternatives, more complex systems. So let's take a look at what program residents or voters actually got. Next slide. The first one is a statewide ballot, and this one goes for the governor and the resident commissioner. This is one that all the voters get, and they're making one for the person that they support. Next slide. Super important one, this is the legislature, how they will be voting for the House and the state Senate. You vote for one representative for the House by the district, 2 senators per district, and then you have to make a choice and select one for Senate at large and for the House at large. Next slide. Lastly, we have the local ballot, and this one you can choose your mayor and the local or municipality assembly. Next slide. This time around, there's also an extra ballot, which is a referendum, a non-binding referendum for a statehood, yes or no. Next slide. So this is one way that voters can actually choose to fill out the ballot, and it's a mixed vote. Basically, you make a mark under the insignia or the logo of a party, and it basically pre-fills the slate of those that the party have listed. But then you can also choose other candidates from different parties. And this way here, you actually see the explicit mark that you don't get on the physical ballot, that when you're making that mark under the logo, it is actually pre-filling or supporting all of those candidates. When there are not as many, basically you just select for the first one. It goes in order. Next slide. Here, for example, if you select more than the number of ballot options, then you get an error message, and it explains, okay, you have to choose one or the other. You can't choose both. So this is something that allows the users to actually think about how they're going to be voting before they actually get to the polling place. Next slide. Lastly, we have a way of summarizing basically a neat way of exporting the results or your choices. People have been like sharing this on Facebook or teaching other folks, older or younger voters, on how to select, make sure that they can have a discourse, a political discourse. Next slide. The support for this tool has been amazing. We got over, as of election night, we got over 450,000 users. 782 sessions that people were practicing, exporting the results, and almost 6 million page views. So it has been broadcast in multiple media outlets. Next slide. So now I want to talk a little bit about the functionality. When you're choosing a tool, you really want to think about what's the functionality that you need. And as we have seen across the morning and the afternoon, that's what should be driving the tools that you use and how. So we wanted to download the files. The government only gives PDFs of the sample ballots. So we needed a way to crawl that with HTTP, use a CSS parser in order to select the links, download those files, programmatically change or transform, convert the PDFs to images, manage or interface with the images, use optical character recognition for the names so we can actually extract the text or their images and then organize the data for upstreaming. Next slide. So why is Julia useful in this task? Well, some of the functionality is quite broad for every language. All languages have a good HTTP library. Most of them has a CSS selector, web drivers, so you can use that quite efficiently. Now, Julia has an extra advantage. That is, it has many packages that are JL packages. That means that you might have a system library that's already built and has been built for multiple platforms. So if you're an HPC, you don't have to be calling your IT or asking someone with system admin access to say, hey, I want you to link this library, or I need to link a different library if you're in Slurm, or downloading that library for that system. With Julia, the package manager automatically has a bunch of libraries that have already been built. Even for Julia, you don't have to compile it in your machine. You can just extract the source code and it's already runnable. So that has been amazing, especially in HPC environments. So I can use the image magic JL package, and then I have all that functionality built in accessible through a Julia interface, but I even having to use Julia to write it. I can just wrap that system library. Images allows for easily selecting those rectangles. And the same way I can use the OC React Julia wrapper, which is just a few lines of Julia code to wrap the C library for Tesseract. And I get all the functionality of that system library with multi-language, optical character recognition with a Julia interface. And this is already built. I don't have to compile it in my own machine. Lastly, Julia has great support for IOs. I use Postgres SQL database on my work, so I can use that library, but has great parsers for Arrow, for CSV, and other IO functionality. Next slide. So just to wrap up the speech here, Julia is great in itself, but it also has a bunch of added functionality through Julia packages that are JLL or wrappers to system libraries. And you can use them quite easily. In terms of development and runtime, I basically did the same thing as another team was doing in JavaScript in order to validate the results. And I was able to do that in 1/10 of the time. And this is just one example of the use cases that I have done. For example, I just updated the legislative voting records for the last couple of years, parsing PDS files, converting to text, and doing all those kind of analysis. For APIs, it's amazing. And even you can use it for cron jobs and other things that I regularly do at my work. So give it a try, especially if you're in a way that you have to struggle with environments on Condas or in some instances, Julia might be an easier way for you to just get and do your work. And it's great for environments and reproducibility as well. Thanks.
All right, thanks so much. Sorry, no time for questions. Our next speaker is, I hope I'm pronouncing this right, Yves Thibodeau, and he's going to talk about integrated record linkage environment. Take it away.
Let's see if I can get this here. Can I get the video, please? Can you go back? Oh, well. Okay. Thank you. All right. Okay, so the talk is about, first of all, thank you, Mike, and all the organizers for organizing that on such a short notice. The talk is about record linkage, linking files, tracking individuals or business entities between files, also known as entity resolution. These are my view as a technical expert. I don't speak in any capacity as an official at the Census Bureau. Thank you. Okay, so what we have right now does pretty well. Actually, we've been using pretty much the same thing for the past 40 years. The new challenges have to do with the number of files that we have to link simultaneously and the size of them, of course. And another thing that's becoming, it's something we have on our mind, and a lot of people have on their mind, is what is the error when we do record linkage? How often are we wrong when we bring two records together? And we would like to find solutions for those two challenges in an integrated way. We want to develop applications that talk to each other on a common console. We don't want disparate programs in different computers. Thank you. Okay, so the traditional way of doing record linkage is called the Felige-Sunter scoring method. We have a number of applications that do that. One is Big Match that was written by Bill Yancey about 15 years ago, and that's a high capacity C program. It does very well, okay, and it's fast. Now, why don't everybody program in C? Well, because it's fast. Well, the reason is because it's expensive to do that, to program in C. It's expensive to pay programmer to program in C. It takes a lot of time. Okay, but Big Match is already written, so we don't have to worry about that. We also have a main application. We call it the SAS matcher. This is the official matcher. Essentially, every file that comes in the Census Bureau that has people information about people is given an anonymous identity number and link to other files to support the information. And so that system is very robust, and we know what it's doing. We've been using it for a while, so we continue to use it, even if SAS, well, it's not necessarily the fastest way to do things. And these systems can process large files, and the problem is, nominally, there's no real-time error estimation. It's hard to estimate what the error is for those programs. However, for Big Match, now we have retrieved, we've dusted up old Fortran programs that run the EM algorithm, and we're hoping to get an estimate for the error. So I'm here talking about advancing in statistical computing, and I'm pitching like C and Fortran programs. So here are two applications. Next one, please. Some of the things we do, one is, you probably can relate to it. You probably got an invitation letter from the Census Bureau to go to the Census Bureau website and complete your census. Now, some people lost their letter, or some people never got it, or whatever reason. They saw a sign on the street that says, fill your census. So they go to the website and they don't have an identification number. So we have to put them on the master address file. We have to find where they're living. That's one application. Another application is we have quite a bit of historical information. So to control the quality of the census operation, we were linking to our historical information to see if people live at the same place. Of course, they don't always do, but it would give us a baseline of what the quality of the enumeration of the field work being done. There's another application in the work. It's called PairSys, which is a data integration application that involves many files that I hope will support us in the future. Next one, please. So we also do the new stuff, okay? We do use Python. The John Cuff in the economic area wrote Mamba, which is a record linkage program that uses some of the new methodology, trees and random forest and so on. Another process can be, of course, integrated in Python. Python is wonderful for developers. Contrary to C, Python is a paradise for developers, but it's not so efficient, right? It's an interpretive language. Okay, so we're still looking at that, and that may as well give us a way to estimate the error of our record linkage operation. Next slide, please. Okay, so what are we going to do next? Well, one possibility is to add sort of a workhorse application in C that process very large jobs, and then do some more refinement work using Mamba, using Python and connecting to a queryable database, for example. And so we're hoping we can integrate these things. And one thing we're interested in also is name recognition. Most of the record linkage I'm aware of use string comparator to compare the name of people to see if it's the same person or the strings equivalent. But there are, right now, there are databases with names that gives you all the nicknames and the spelling variation. And so in real time, we could look that up and enhance our operation that way. Next slide, please. Okay, so what is the real future? That's something that personally, as a technical expert, I like using Markov chain Monte Carlo. Okay, think about record linkage. It's a pretty demanding computational endeavor, right? To link, files can be 500 million, like Cecile was mentioning, linking a 500 million file to another 500 million. I mean, this is quite demanding. Now, if you go to the world of Markov chain Monte Carlo, to the Bayesian world, well, then you do it 100,000 times. the same record linkage operation with a probabilistic variant each time. So you get a full characterization of the process and you get an idea of the error. It's a little bit much these days to do something like that. Rebecca Stewart, who has developed one of the program that does Markov chain Monte Carlo, actually as partner with Ted Inamorato at Chapel Hill, who wrote FastLink in R. So the idea there is to boost the Markov chain Monte Carlo so it doesn't spend as much time in details in these areas where there's a low probability, where it can get stuck there and spend a lot of time. So we're hopeful about that. But that's really a research research effort. Okay, next one. Oh, wait, okay. You guys have any questions? Just don't hesitate. I'll be happy to answer to the best of my knowledge. Thank you very much.
Yeah, thanks so much. It doesn't look like we have any in the chat right now, but if you want to keep an eye on that, just in case anybody has some afterwards, that'd be great.
Okay.
And
I will look at that. I'm not so good at processing in real time myself.
all right.
I'll be happy to answer your question.
Okay, yeah, thanks so much. Yeah, none right now. So our next speaker is Alexander Priest, and he's going to be talking about automating static data visualizations.
Thanks, Brandon. Is it okay if I share my screen and share the presentation that way? Thank you much.
Sure, go ahead.
All right. My name is Sandy Price. I'm a data scientist with RTI International, and today I'll be talking about the process that we've developed to automate static data visualization in Python that we applied to a COVID-19 project recently. And what I hope the main takeaway will be for you all today is that generating routine reports in Word, PowerPoint, and Excel does not actually have to be a nightmare, contrary to popular belief. And in fact, you too can create them using a single line of code. We'll get there by starting with a common scenario that I think will illustrate why I believe this is a useful approach for many of us. I'll give you a little bit of background on the project that we use this approach for, and finally talk about it in a more general way that I hope will give you a little bit of a roadmap to potentially using this in some of your own projects. So let's consider a common scenario. I bet this is something that has happened to every single person at this conference at least once, maybe lots of times in their career. So you have a client or a partner that says, I need this nice, pretty summary of the data. I need to share it with this group of people on a regular basis, and it should be really nice to look at and really easy for me to share. So probably our first recommendation in that kind of scenario is going to be a dashboard. Fill in whatever fancy technology that we like to use at the present. And we would hope that that would be the perfect solution, and the client will be overjoyed and tell us how smart we are. But a lot of the times, we end up in a scenario like this, where the client says, well, that's cool, but we don't really have a server, and we can't really pay for putting it on the cloud, and like, we'd have to go through all this legal rigmarole to do that. And by the way, did I mention that we need this next week? So not always our favorite outcome, but definitely a common one. And the point is that in some projects, the old-fashioned way really is the right way. And some common constraints for that: timeline, security issues, computing capacity. Sometimes we just have to make those old school reports. But as I'll show here, we can still automate a lot of that process using some nice Python packages. So a little bit of background on the project that led us to develop this. This is a COVID-19 rapid response project with the North Carolina Department of Health and Human Services. They reached out to RTI in the early days of the pandemic and basically asked us if we could help them forecast hospital demand under different scenarios of COVID-19 spread, ultimately to see if and where in the state it was likely that COVID-19 would cause hospitals to run out of capacity. And their goal was to incorporate this information in weekly reports that they send out to their local health departments and to prioritize resource allocation. Now, because this was rapid response, and because they needed to integrate it into a bunch of other reports that they were already doing in Excel and PowerPoint, we settled on this deliverables package that included basically lots of Excel and PowerPoint files. We generate raw output in Excel, visualize it several different ways in PowerPoint and Tableau in different scenarios of potential COVID-19 spread. And they use these in various ways. Their epidemiologists might play around with the data in Excel. They might take some of the PowerPoint slides and integrate them into the other PowerPoint decks that they share with their local health departments and so forth. So because of the needs of the client and because of the timeline in this rapid response project, it really made a lot more sense. It was a better product for them to have these kinds of Excel and PowerPoint deliverables than for us to put together some kind of web application or dashboard presenting the information to them. And also, I should mention that we generate these deliverables for DHHS once a week. So that led us into this situation where it was really just not feasible to do that by hand. There's no way that anybody could spend their time generating 8 different Excels and PowerPoints every week after each model run. And even if there was, we wouldn't want to make somebody do it. So we used several Python packages to automate this process to a great extent. And the first one, which I won't talk about as much today, because it was mostly related to the Excel deliverables. It's called Excel Wings. This is a really nice Python package that basically allows Python to get behind the steering wheel of Excel. And we use that to take the raw model output in a CSV format, Format it really nicely so it is easier on the eyes and easier for someone to use. Add a README, that sort of thing. Definitions and disclaimers and all that sort of stuff that we want to put on the data before we send it out, and then save it as an Excel file. The two that I will mostly talk about today are matplotlib, which anybody who uses Python is probably familiar with. This is sort of the standard Python plotting package. We generate 90 plots from the model output data each week using this package, very easy and efficiently. And the really cool one that was a new discovery for this particular project is called Python PPTX, which kind of like Excel Wings will let Python get behind the steering wheel of PowerPoint. You can both generate PowerPoint files from a template and then add different components to slides within the presentation, all by writing Python code. So stitching all this stuff together, if you think back to that slide that we showed with the list of deliverables, we generated all of those, the various PowerPoints, Excels, the data files for Tableau, with a single shell command, generate deliverables.sh. And it's a whole lot nicer to do that than it is to go through and make all of these things manually. So now I'm going to talk about the approach in a little bit more of a generalized way, in hopes that you guys could start to think about how this might work for some of the projects where you might be making some routine reports and like to automate them. So I think we can split our approach for this project into 4 steps. The first is to make a PowerPoint template, then to use Python PPTX to make new PowerPoint files from that template, generate all of your plots using matplotlib, and then the piece that ties it all together, using that same Python PPTX package to put the plots in the PowerPoint files in the right place. And again, the 2 packages we're relying on here are matplotlib and Python PPTX. So step 1, you got to make a template. So some of the stuff that's just going to be the same on every single presentation. We don't want to have to do all of this in Python when it's not really necessary. So this is the template that we started off with. These are just sort of the things around the margin that we're going to keep on every slide. And then all the actual content is going to go into that big white space in the middle. All right, so getting into the meat and potatoes here. Step 2 is make new PowerPoint files that you will actually add content to from that template. And I do have some kind of pseudocode on the next few slides here. This is just a much simplified version of the same approach that we're using in the production code for this project.
3 minutes.
So we define a function to make new PowerPoint files and just have a parameter for everything that needs to vary across these files. So we need to make a PowerPoint file for each scenario of COVID spread. So we just include that as a parameter. And in your case, you would just repeat that for whatever variable you might need to use to generate different PowerPoint files in your project. And then the content of this function is the PPTX package, just going through, adding text boxes, that sort of thing, and then saving it as a new PowerPoint file. And then we just use a loop to go through and generate all the PowerPoints at once. Step 3 is to generate the plot. Same setup here. We're going to define a function with parameter for every variable that varies across the chart. So in our case, we want 1 plot per region per variable. Generate it with matplotlib, save it with a common naming convention, loop through and generate them all. And the output here is just going to be a bunch of plots like this, but with the file names so that we know what region and what variable they're reflecting. And then to tie it all together, we have a function to open a PowerPoint file and add plots to that slide. So we just tell it which PowerPoint file, which region, and which slide. In your case, again, you would just replace these with the parameters that vary across your PowerPoint and across the different plots. And then use that Python PPTX package, really nice functionality to open the PowerPoint, to open the presentation that you made before and insert the plots that you made before. Again, just looping through all of our different scenarios and regions and inserting all those plots into the PowerPoint. So we go from our template to a nice filled slide. This is 1 slide out of a presentation with 11 slides over 3 scenarios. You can really start to see how doing this stuff automatically is a huge, huge time saver over doing it manually. So in conclusion, I hope this has shown how we can use Python to automate the creation of this kind of routine report. In this case, it allows us to generate 6 different deliverables with a one-line shell command, which is not only making our lives a lot better, it was pretty vital to the success of this project because we had to be able to have that rapid turnaround and rapid response to get this information into the hands of the health department. And I do think that this is pretty generalizable to your project. I hope that you guys can find some scenarios where this might be useful to automate some of the routine reports that you're currently producing. I want to thank the COVID-19 healthcare capacity modeling team at RTI, our colleagues at the North Carolina Department of Health, and my contact info is on the screen. I'll stick around and answer questions in the chat. Happy to answer emails later on. Thank you.
Awesome. Thank you so much. All right, next up we have Drake Gibson, and he'll be talking about web scraping of work stoppage information.
Yes, good afternoon. This is I want to thank everybody, all the organizers and all the attendees for coming and giving me the opportunity to present this. So as you can see, this was a proof of concept by me and David O, who's also in attendance. We were trying to automate the web scraping, the product line for work stoppages by scraping the information. Thank you. So what we're going to talk about today is the work stoppage program, the actual web scraping project itself, the motivation, back-end process, front-end, and future improvements. Next slide. Okay, so the work stoppages program is a Bureau of Labor Statistics program line, product line that provides monthly and annual data and analyze that data for work stoppages. So the work stoppages involve 1,000 or more workers that actually stop work for lasting 1 full shift or more. All that information is available on our webpage. I just want to kind of skip through it just for time purposes. Next slide. Okay, so what we're actually trying to automate is the data collection and processing part. So for the whole product line itself is a monthly product process of collecting, processing, and then disseminating the data. Next slide. Okay, so what we're going to be talking about today is we're going to go actually through the primary objective, which is the web scraping article, annotate the article, build a prediction model using the annotated articles, and then apply that model to improve everything, and then prioritize the ones that are likely, and then re-annotate those models again to create a better model in the end. Next slide. So the motivation for this was for our Census of Fatal Occupational Injuries program. They have a web application called CPDMS, which they actually use Google Alerts to pull in the information, annotate the articles, and pull up the relevant ones. So it's full page of web results, and they're also saved as text and PDF, and it's updated daily. Next slide. So for the backend process for this, we're actually using RSS feeds for ProQuest. Originally, we're using Google Alerts, but with the pandemic, we had to start actually working from home. This actually caused us to not be able to go around our firewall to actually get Google Alerts and update our information and actually run code. So originally, that's what we were doing, and David and I decided to use ProQuest to do this. So what we do is we read in the RSS feeds, leverage the article links, scrape and clean the information, score and store. Everything is stored in an Excel file. Right now, we are looking to move to a server. Next slide, please. A server or a database. So basically what we're going to do first, we update our RSS feeds every day for strikes, work stoppage, walkout, labor dispute, and sick out. These are the search terms that we use within ProQuest to get all of our batch of articles. We then scrape the article text using RVest. We then scrape and clean them using the article link. ProQuest has a special article link for each article. So if you go on ProQuest, search the article and pull it up, that link is actually not the one they use to actually store the article within their database. What we do is we apply a machine learning score to each article. We've used it based on union names and the word local, because local applies to local unions within a certain jurisdiction. We also use a number of workers. So if it's 1,000 workers, that article should be something that we keep to be reviewed. Then we append it to a master file. We have one for every day, the current month, then a master file, and then a new master file that's going to have the actual date published and the actual source. Next slide. For our front-end processing, this is our work stoppage environmental scan version 1.0. As you can see, it kind of looks like the CPDMS one that we created. David actually built this one using tkinter and Python. It looks very nice. Next slide. So for this front end processing, you can see we have a screenshot of the article. This is what it would look like. You're able to search articles based on keywords or just based on the text within the actual title. You were able to annotate it, either calling it relevant in scope, and also label it for tracking purposes. We have the actual link to the website. We have screenshots available if you can't actually access it via the web page itself, in case that the link may die. Also, one of the best parts about this is you have a related articles portion at the bottom, which is created using TF-IDF, to then look at similar articles and pull those articles together, because one source may have different information than another, and you also may have an updated story, which you can kind of keep track of. And as you can see, this is one of the more relevant articles because UAW is a very large union and displaying a strike. Next slide. You'll see some of the text kind of pop up, but I just wanted to kind of cover all of that in this slide just to make sure I'm going to be on time. And as you can see on there, you can see the ProQuest page itself, and we actually can launch it from there. So one of the biggest parts about this annotating the article is so we can actually go back and perfect our model to make sure we have the correct articles being displayed to the product line users and reviewers. So you'll see relevant, whether or not it's actually talking about a workshop is related topic, if it's in scope or something that's related to what we've been looking for, if it's an event that is in scope for here. And then also you can label it for tracking purposes, which we are also going to try to refine as we actually put this into production. Next slide. On the left-hand side, you can see the search option, so you can filter you can filter articles by terms, keyword, which is in this great article, the annotation, the label, and also look at a specified date range for these articles as well. We've been scraping since about, I want to say February or March, so we have a pretty good baseline for articles that may or may not actually be relevant. In the future improvements, we're looking to leverage other news sources now that we have a way to kind of work around our firewall to get this information. We're going to refine our web scraping because there's always a way to do this a little bit better. We're in talks with ProQuest to kind of have them help us with that. We're also, like I said, going to be trying to adjust our scoring for better results to make sure our model is better and produces the correct information for the users. We also are going to be using, hopefully, a database or server to actually store everything. For the front end, we're going to improve window scaling, try to get better with the TF-IDF for better article recommendations, and also try to make it a little bit quicker. We may be migrating this into a web-based application, but first we want to test it with the product line to see how well it works and do a parallel test to see what we have done better or what we can do better in the future. This is our contact information. So mine is gibson.drake@bls.gov. David O is o.david@bls.gov. We also have a group email as well. You can email both of us and we can give that to you also. Thank you again for the time. If you have any questions, please go ahead and let us know in the chat. Thank you, Brandon, for your assistance.
Yeah, thanks so much. All right, so next up we have Kevin Hunt, and he'll be talking about automatic production of large spatial price rasters with Python.
Yes. Okay, so hi, I'm Kevin Hunt. I'm with a geographer with the National Agricultural Statistics Service, and I'm presenting on automatic production of large spatial price rasters with Python. And this lightning presentation will focus on the Python library ArcPy. And there's our typical disclaimer. Next. So the overview of this project is we're focused on, NAS is focused on developing a machine learning pre-season prediction models for acreage of corn and soybeans right now. And this data set includes geolocated agricultural commodity prices. And there are some steps to get that price data in a high resolution, which is what we want. We want 30-meter resolution. So that's the premise of this. First, you want to scrape the data from a host website and format it. And for us, we're doing monthly averages. Then convert those tables into feature class files, point features, And then you want to convert those points into inverse distance weighted raster surfaces. And that is IDW surfaces is what we're calling of it. And then the last step is learning model. Next. I'm going to focus on these two steps, 2 and 3, because that's the actual Python library, ArcPy. And next. So I wanted to kind of step back and show you the product we're headed towards, just so you kind of understand what we're doing here. So we're taking elevator price grains that are geo-referenced, and so in Illinois there are a lot of those, and those prices can then be converted into these IDW surfaces that then can be used for a high resolution model. This is a base price, which is the price the farmer gets paid, and then a future contract price is if you sell your corn or whatever commodity at an X amount of time later, you can be given a price called a future price. Next. So to get the data, first, it's coming from a website company, GeoGrain. They are the ones that have this referenced data, and it's XML file format. You can pull it down through any kind of coding. We use R, but I'm also wanting to use Python in multiple ways. But really, you need to just take those steps that I have below, and that's how you can get your data. Next. So this is the meat of it, the details of the Python for the coding. So anytime you're working with geospatial data and you want to use ArcPy, you need ArcGIS Esri, which is a proprietary software, but you can then access their Python features and their Python library when you make that connection in your interface for Python. So first you want to import ArcPy. This is to make the, convert the tables to points. And so we're working with DBF tables. That's kind of what we're working with this geospatial data. So first you want to import ArcPy, and you need to know what the tool is going to be in. So it's actually in the management tool suite. So that's where you're importing the management. Then you have to set your workspace. So it's arcpy.env.workspace, and then that's where you can define it, and you can then define where you want to put those files. So the real automation part is this looping tool. So this is where you want to loop through all the files you have to then make it sequentially make all of these point files. So it's called ArcPy list files, and that will give you a list of all your tables. And then from there, you can format it. I'm formatting it here to make it a DBF file with the name that was already taken from the file name. And then the next step is you're going to use that tool to then loop over that data. So you've made the loop called DBF list. And so in the ArcPy management, which I described earlier, there's then the XY table to point tool. And that's how you would write it. And then each piece inside the parentheses is the parameters. So the in table is the DBF, the out feature is where you're putting it, the X field is the longitude, the Y field is the latitude, and then you always have to define your coordinate system so that it projects correctly. And this is a web Mercator. Next slide. So then once you have all your points, which once you run that, then that's what you have. And in my case, I'm doing 20 years, 6 months. So it really adds up. It can be hundreds of files. And that step takes some time to do, but not a lot, but it does take time. So then when you've gotten to there and then you want to make your IDW surfaces, you have to go through the same steps at the beginning. You want to import ArcPy. This tool is in the spatial analyst suite. So you also need to import SA, which is spatial analyst. And for me in this project, I was also using OS to just rename some things. So I can describe that later. So you import that at the beginning. And then like before, you define your workspace and your outspace. And then this is where you loop again. So this is the looping tool to loop over your feature classes, which is a different tool. So to get your points and have a list of all your points, you go arcpy.list feature classes. And so a feature class is a point file. So in GIS, Geospatial Information Sciences, you have multiple files that make a shapefile or make a feature class. So that way, this tool will let you know how many individual points they are. So that's a key piece. And then after you do that, you want to then set your parameters so that when you're looping over your files, your tool knows to use the parameters that you defined earlier and where they are. So Z field is the value. So in this situation, it's the price. And then you want to define your cell value. So that's 30 meters for this project. And then in the math of an IDW, you need a power 2, and we do 2. And then there's a search radius, and you can do that differently, but search radius is radius variable. And then we have up to 5 points, and we wanted to look out to 70 miles, and that's in meters. Next. So then just before you can actually then run the tool, you want to make sure you're checking out your spatial analyst license. And this is just a technical detail about ArcGIS. You have to have a license. That's another piece to this. But I thought it was important to point out because you want to know that. And then here's your feature class. The FC is the list of your points. You want to then use that in the environment manager tool, and you're defining now what projection you're going to put these IDWs in. And I'm actually changing the projection here to match other data. And then you want to then save the ID, or then you want to use the IDW tool, which is arcpy.sa.idw. And then there's your parameters that you defined above. So then that's all it is looping through this. To make, for my study area, the Illinois area, each one of these is about 15 minutes on a standard computer. So you then are looping that over hundreds. You really want to save some time there. And now here's where you can rename the name. And this is pretty straightforward, but we're saving these in IMGs, which are Imagine files. And Imagine is, I'm going to describe in the next step, but that's a detail for this project. And you can change the name and join the new name there. Next. So this is the final kind of output of the IDW service. So in our earlier code, we scraped from the web. We wanted to just do an area around Illinois, but you want to capture the grain areas outside of Illinois, just in case you live along the border. So then we clip Illinois, the shape of it, in Erdas Imagine. And then you want to fix your pixels to the defined extent. And that's a detail for this data merging that we want to do in this machine learning project. And so there is a way to loop in Erdas Imagine. And so I wanted to write it down here just for a little details, but you can make a model maker and you do your 2 steps there. It's a GMD file. Then you can generate a script, which is an MDL file, and you can edit it to have an in and an out file. And then that's called, and you save it as a batch command file. And that will then allow you to loop over all of these files. And then it can make those shapes, like you can see in the upper left, all fit. And then all your data is ready to run in the machine learning model. Next. So in summary, this streamlined the workflow. So I'm a researcher. And so first you figure out how to do it, and you can do it through the brute force. And we did it through the brute force and quickly realized, okay, if we're going to adjust the data or ever add on to the data, we need to streamline this. So that streamlined it, doing it in this code. The automation of this increases your speed just by not having the labor. And then of course that reduces error, because you always know when you're doing things by hand, you can add a number or forget something. And then the whole process can be applied to all kinds of data, especially IDWs where it's relevant. You can, create surface data from point data. And this is a key piece to the kind of research we're doing right now. And you can apply this stuff to any kind of model, machine learning model. So next, that's pretty much my quick example of ArcPy. And if you have any questions, feel free to email me or ask it in the chat. But I think we're about done. Thanks.
Yeah, thanks so much. And so our final presentation of this lightning round will be from Kristen Chen, and she'll be talking about using deep learning to classify open text field comments.
So thank you. Hi, everyone. This is Christine Chen from WestStat. So today my presentation is using deep learning to classify open text field comments in a panel study. So first, I would like to acknowledge my coworkers, Catherine, Andrews, and Gonzalo in this project. Next, please. So the open text field comments are entered by interviewers to request data updates or corrections in a data collections period. This type of the field comments usually requests costly and most of the time manually data processing after transiting back to the home office. So in order to improving the processing efficiency, the interviewer requires to select a list of broad categories such as health insurance, employment, or prescriptive medicines before entering the comments, because it narrows the scopes for the post-processing. Next slide. So the service operation team would like to know that can machine learning help to determine the correct comments categories in a more efficient way. So it's a typical text classification problem. The data we have, it's about 8,000 points. The comment it's classified to 10 categories. The proportions for the data in each category is imbalanced. So if you look at the table I have in the slide, we actually have about 6 classes. It's equal or less than 10% of the whole training data. So it means that we have to take care of data imbalance in the model training. Next, please. So the first method we have is to extract the handcraft features, convert the work using TF-IDF work embeddings, and fit a linear model. So this work setup is currently running in productions. So the extracting features are mainly from 2 resources. The first resource surveys metadata. So we have question numbers and field names where the comments entered it. And the second set of features are derived by the understandings of the key information presenting in the sentences that could help predict the category. So if you look at the examples I have on the slide about the first comments, the model understands that AARP, it's not only an organization, but also an insurer. And we think this feature can improve the probability to classify these comments into the healthy insurance class. And this idea is applied to the drug and medical provider features too. The underlying technique is name entity recognitions, and we also have the strength matchings based on the strength distance of the keyword in the sentence against the external reference database we have, which contains all the insurers, drug and medical providers in the market. So I think the point here is that the key information for prediction actually exists the language itself. So if you look at the first example here, by name entity recognitions, the model is able to understand Nancy and Grace Young belong, it's a person's name, but we add one more layer on top of that to exclude the detections for Nancy because it's a respondent's name, but really flag the presence of Grace Young because this name belongs to a medical provider. And we think these features, it's improving the probability to classify these particular comments into a healthy care event. And this knowledge is actually, the handcraft features try to supply this knowledge into the model. Next slide, please. So based on this setup, we end up have an ElastiNet model. We train the regularizations parameters, and we have 76% classification accuracies across in 10 classes. So next slide. we try to compare these methods with the deep learning natural language processing model, because from the literature, we understand that deep learning enable multi-level automatic feature representation learning. And this is a more advanced technique than the traditional machine learning NLP system that relies heavily on handcraft features, like the one that we have in production. So we would like to know that can a deep learning model outperform the model we have in production? So the first method we have, we still keep the abstracting features, and then we fit a shallow neural network. So the architecture you see on the slides, we have only one hidden layer and one classified layer on top of that. Next slide, please. And we tune the learning rate, batch size, the number of apples, and weighting the classes based on the proportions in the training data. And then we have the overall classification accuracy is 69%. Next slide, please. And the third method is that we try to go full automated. We fit the pure commerce, no pre-processing, no cleaning, no extracting features into BERT. So BERT is, stands for bidirectional transformers for language understandings. And it's a state-of-art deep learning NLP model released by Google in 2019. So it's considered as a game changer in this field because it provides deeply bidirections unsupervised language contextual representation. So for the computation purpose, we use the disk-to-BERT, which is the disk-to versions of BERT. It reduces the size, running faster, but still retain 97% of its language understanding capabilities. Next, please. So as you see, we fit the pure commerce to disk-to-BERT for sentence classifications on TensorFlow. This is the architectures. And next slide, please. And then we tune the learning rate, number of apples, batch size within the classes, and then we have accuracies, 66% across in the 10 classes. So next slide. So overall, we compare 3 models, and the one ElastiNet model trained on the extracting handcraft features, and the TF-IDF word embeddings outperform the rest of 2. And this is what we're understanding. The key to distinguish the class among field commerce mostly based on the presence or absence of the key information, which are captured by the handcraft feature. And this knowledge exists the contextual representation captured by BERT. So the advantages for the BERT, any deep learning network is able to understand deeply relationships between the text sentence in the documentation, but disadvantage don't really add values to our classification tasks because we simply, thank you. We simply just need to know that whether or not that's a medical provider existing in the sentence, but we don't really care about where these informations exist in the sentence and how the information related to the other vocabularies in the sentence, or how the interviewer described this information. So next slide. So the main takeaway for this practice is that superior deep learning like BERT don't really apply to our problem. And my thought for this practice is that because given that's a lot of state-of-the-art deep learning model in this field, so people have impressions that they can just dump in, their training data into these big giant black box models and think that they can obtain a good result. But my understanding is that rigorous research, data understandings, and handcraft feature engineering shouldn't be underestimated or underappreciated in generalizing general natural language processing or understanding tasks. Because in our case, actually that approach performs better. So next slide is the reference, and next slide it's my contact information. So thank you so much for listening, and I will take questions in chat. Okay, thanks.
Thank you so much. And thanks to everybody that was in this panel, this lightning round. And if you do have any questions for them, please try to find them in the chat and ask your questions. And so I'll leave it to Mike if you have any updates. Otherwise, the next session will start at 4:25.